All right, so we finished the video right here and send it over to, yep, right here. And there we go. Now I can upload that to Schoology. Oh, hi there. Just working on some school stuff. Now, last lesson we learned a lot about what the trigonomic ratios are. But this lesson, we're actually going to end up learning a little bit more about how we use trigonometry to find a missing side or find a missing angle. And that's today on geometry. So let's talk about trigonometry. So last class we learned what the trigonomic ratios were: sine, cosine, tangent. And this class we are going to actually learn about how to use those different ratios. So before we do that, a quick note about calculators. First thing that you need to know is you will need to use a calculator to solve these for missing sides or angles. In the olden days, before calculators were around, a lot of times certain specific sine, cosine, tangent levels would be memorized. And you'll memorize those whenever you get to pre-cal and calculus, some of those. But there would be tables that you would have to use. We don't use those. Instead, outside of the ones that you were supposed to memorize eventually, these are all now done in a way in which you will just do them in a calculator. Now, if you are needing to use your phone because you don't have a TI-84 or a TI-83 or any of the TI calculators or some other calculator that happens to do sine, cosine, and tangent, you should not use the default calculator. Technically, it will run those, but do not do that. I recommend using either Desmos, which is available on iOS, Android, it's available on the web, or Calculate 84. Calculate 84 is on iOS. It is not available on the web, and it is not, at least for now, available on Android. There are, I'm sure, good Android ones that are similar to this, but Calculate 84 is basically a TI-84, but not for legal purposes. These are both free as of right now, which is still technically February 28th, 2021 when I was recording. Once you have a calculator, though, you actually have to make sure that it's set up, because if you don't, you're going to get things wrong. And that means setting up the calculator to be in degrees instead of radians. So let's talk about that. How do we set up a calculator to be in degree mode? So I'm going to actually start, because I'm not going to use this for most of it, in Desmos. So here we go. Boom, it's up. So if I want to do things in Desmos, I'm going to need to look at function. And if I say the function and I say the sine of 32. Okay, what if I say the sine of 24? Oh, look, that's a negative. I will tell you this. If you ever see a negative, then you are definitely not in the right spot. So be on the lookout for that. Instead, what you're going to need to first do is actually be in degree mode. You see, radians are based around how many radiuses around a circle there are. So there are pi radians in, well, 2 pi radians in a whole circle. So pi radians is 180 degrees, but you'll learn all of that in pre-cal. For our purposes, you just need to know that you need to be in degrees. So I clicked on the little wrench button in the upper corner, the settings, and if you look at the bottom setting that we have, it says radians, and I'm going to click degrees. Now if I was to write sine, so I went to function, sine, and I said 26, notice it is now positive, which is what I am looking for here. All right, so now let's move on to the TI-84. If you are using Calculate 84, Calculate 84 is going to work exactly the same as this is. So what you are going to want to do is you are going to want to press second, or you are going to want to click just mode, not second mode, and then you're going to want to look down. I already have mine in degree, but it's the third line over. You want it to be in degree not radian. If you ever have to reset your calculator, you will have to redo this. So please be careful and be on the lookout for that. But you want it to be in degree mode. Clear. I can double check by just writing sine of 26. 23 will work too. And see, I'm positive. So there we go. All right, so now that we know that, let's get started on trying to solve some of these. All right, so here's our first problem. It says x is equal to, or is approximately. So what I want to do is I want to go from this angle. This is the adjacent, and this is the hypotenuse. And quick reminder, so ka toa. So SOHCAHTOA, we have adjacent and hypotenuse. That means we are on cosine. So I'm going to say, let's see. The cosine of 74 is equal to adjacent over hypotenuse. All right, so let's see. If I want to get x by itself, I have to multiply both sides by 9. So 9 and 9. And then I'm just going to put that into a calculator. I'm going to type 9 cosine 74. Ooh, that doesn't look like that got right. Let me double check and make sure. Okay. Yeah, no, wait, that is right. I somehow now was thinking I was looking for the hypotenuse. So yeah, 9 cosine 74, which means x is approximately 2.48. Approximately. All right, let's try another one. Okay, so from this angle once again, opposite, adjacent. So ka toa, and this is the one that we have. So let's see. The tangent of 52 is equal to 8 over x. So I want to get x by itself. So let's see. I would multiply. I want to get x on top first. So I would do x tangent of 52 is equal to 8, and then divide both sides by the tangent of 52. So x is going to equal 8 over tangent of 52. I put that into my calculator. So let's see. 8 divided by tangent of 52. Enter, and that is going to get me approximately 6.25. Let's try another one. Okay, so from here, opposite hypotenuse. So ka toa. In this case, that's sine. So the sine of 37 equals 12 over x. That means x is going to equal 12 over the sine. Ooh, let's rewrite that. Let's actually write this. X times the sine of 37 is equal to 12. And then we would divide by the sine of 37. So we're going to do 12 divided by the sine of 37. Now, if this is correct, x will be bigger than 12 because we are looking for the hypotenuse. So 12 over the sine of 37. Enter. And that gets us approximately 19.94 if we round to the nearest hundredth. All right, now we're looking for an angle. So let's look at what we have here. So we have, once again, opposite and hypotenuse. We just did this one, so this is going to be sine. So I would say the sine of x is equal to 4 over 5. Ooh, that's, 4 over 5. Okay, so here's the thing. If we look on my calculator, I can't just suddenly divide by sine. That doesn't work, but I kind of can. Because what I would want to do to get rid of sine is to do something like 1 over sine. So, looking back at my calculator, let's look at what we see over here. So sine is, look right above sine. Look right above cosine. Look right above tangent. Do you see it? It has this inverse sine. So inverse sine is what we use whenever we are out to find the angle. And then I'm just going to write 4 over 5. And that means x is approximately 53 degrees. All right, let's try it again. So in this case, this is going to be adjacent hypotenuse. So that's, let's see, it's not so, but it is cosine. So we're going to use cosine in this case. So the cosine of x is equal to 7 over, sorry, not 7 over 3, 3 over 7. So I just write that, but I have to use inverse cosine. So second cosine, 3 over 7, enter. And that is going to get me 64.62. Okay, and one more. All right, this is opposite, this is adjacent, and since we've already used sine and cosine, I know this one's going to be that the tangent of x is going to equal 8 over 3. So I go in second tangent 8 over 3. Enter. So that gets us 69.44, or I'm just going to say approximately 69. So there we go. Let's talk a little bit about word problems. So I'm going to take away the calculator for just a sec. So before we can talk about word problems, we need to know about a term. That term is called angles of elevation and depression. So an angle of elevation is an angle formed by a horizontal line and a line pointing above it. So it's going up or elevating. Now, an angle of depression, as you might be able to guess, is an angle formed by a horizontal line and a line pointing below it. So it's going down, which would be considered a depression, going down. So now that we know those two terms, let's try out a math problem. So this says a forest ranger is in a 120-foot observation tower and sees a fire. The angle of depression is 3.5 feet. What is the horizontal distance between the tower and the fire? Round to the nearest foot. So we have our tower over here. And we know that the distance to the tower, at least to where this person is 120 feet. And this person is looking out. And he looks down and he sees himself a fire. Oh no, the fire. And so he looks down. Oh no, this angle is 3.5 degrees. And so I am looking for the distance from, I am looking for this distance though. So I am looking for this one. So the question is, what is this distance? So what you might be noticing here is I actually don't have an angle that I'm currently using. Now, I actually do in that this is 3.5, but I like to consider this because I think most people see this a little bit better. So what I'm going to do is I'm going to do 90 minus 3.5. that gets us, that gets us 86.5 degrees. Let's write that a little bit better. 86.5 degrees. So that is our angle. So that is the angle that we actually need. So our angle, and so let's see, the height is 120. So that's adjacent. And this is opposite. That means that we are actually using the tangent. So tangent of 86.5 is equal to opposite over adjacent. Okay. Now that I have that, to get x by itself, it's just going to be 120 times the tangent of 86.5 is going to equal x. So let's bring back up the calculator. Oh, let's also clear that out. I'm going to write 120 times the tangent of 86.5. And that's going to get me that the distance is 1,961. Oh, nope, because we're rounding to the nearest foot. 62 feet. All right, let's try our next one. To measure the height of a rock formation, a surveyor places her transit 100 meters from its base and focuses the transit on the top of the formation. The angle of elevation is 67 degrees. So we are at the bottom of a beautiful rock formation. All right. We have a surveyor right here. What beautiful art. So there we go. And the surveyor places her transit. Her transit is 100 meters from the base. So this is 100 meters. And the angle of elevation is 67.5. And what a perfect 67.5 we're looking for. So the question is, what is the height of the rock formation? We also need to know that this height right here is 1.5 meters. So we are out to find x plus 1.5. So first off though, let's see. So that's opposite, adjacent. That means tangent again. So we are going to write tangent of 67.5 equals x over 100, which means 100 times the tangent of 67.5 equals x. I'm going to put that into my calculator, which I still have up. 100 times the tangent of 67.5. And that's going to get us 241.2. But here's our problem. We're actually 1.5 meters above this because remember, that was going from where the transit was, not from the ground. So 1.5 is going to actually get us, if we add 1.5 to this, to where we are now at 242.9, which means this is now at 243 meters. And there we go. One last thing that I would like for all of you to do, and that is I would like for you to like and subscribe. This is the last lesson for this unit, but I will be seeing you all again for probably the review if you're in my class, and if you're not, I'll see you all for next unit if you really, for some reason, want to watch math videos. I don't know who hurt you, but okay. All right. Have a wonderful day. Thank you all very much. Goodbye.